Okay, good morning from Switzerland. Happy to share with you today the webinar of the future of flaw detection using the Proceq UT8000. I'm Chris Udell. I'm the product manager for flaw detection at Proceq, a screening eagle company. Oops. So today we'll start by doing a brief introduction, look at the market of ultrasonics, especially with the current pandemic conditions and how that's been affected. Then we'll go into introducing our product and how we can help in solve some of the issues that's been caused. Then we'll look into the software and then have a look at other items in our metal portfolio that can perhaps help you too as well. Then we'll go into about 10 minutes of questions and answers if you wish. So as an introduction, ultrasonic testing is used at all stages of production, all the way from initial raw material to on-site inspection and in-service inspections. We've seen during the pandemic that manufacturing has slowed down to almost a stop. And in China, it's now starting to ramp up again. And we'll see the same trend in the rest of the world too as well. Service inspections, except for the aerospace industry in oil and gas and power, have still been continuing as we're in this situation. The advantages of ultrasonic testing is that it's a volumetric method, and it's used to detect surface and subsurface defects and discontinuities. You can have good sizing and you have an instant result, no waiting back. You also have minimum part preparation, such as you don't need to prepare the surface as much as you would with dye penetrant, and it's not hazardous. You don't use dangerous chemicals or radiation. You can see in the charts at the side that the top one over here is the number of power plants around the world. There's around about 30,000 of them. There's hundreds of millions of kilometers of pipelines. And there's typically, not at the moment, but there will be soon, typically 20,000 flights a day, which all have critical defects in there that need to be detected. And if they're not, there could be some problem. So we estimate that even with this pandemic going on, there's 100,000 inspections per day. The corrosion won't stop if the pipelines and the power stations are still operating. So we still need to inspect things despite the whole world being in some form of lockdown. We believe as well that inspections should, in the future, there should be many more inspections. So this will help as well. So let's have a look at the evolution of equipment. Back in the 1950s and 60s, we had the analog system you can see here. This required the detailed analysis of an A-scan by an operator. It was very simple to use. You had typically 3 controls for the gain, the range, and the delay. And the signal response rate was very quick. Then about the 1980s, early 90s, whole industry switched to digital flaw detectors. We did lose some kind of performance with that, but we got items such as gates, embedded DAC curves and wizards to set up, but we lost some signal performance, but it still required the detailed analysis of an A-scan by an expert operator. And now we can have a look at what's next. And when we have a look at what's next, we can see the current trends in other industries worldwide as well. So what we've noticed in the current pandemic situation is that remote access is super important. Now being able to view data and communicate across borders, across sites and locations is very important. We've seen companies now accelerating their digitalization strategies. If they've not already started, they've definitely started now. And that's actually shown that we can be just as efficient working from home as we are in the office as well, especially for meetings and other things like that. And we've seen that the digital divide has been widening. So those who have got digitalization in their strategy are now becoming much more differentiated for ones that aren't considering that as well. And we'll see those ones who don't consider digital to be important slowly fading down in there. So now we can introduce our response to this, the conventional ultrasonic Proceq UT8000. It's a future-proof digital flaw detector for the next generation of flaw detectors. We start by looking at the hardware. We have a lightweight aerospace alloy, which is also IP67 and drop-proof, but we've still managed to keep the weight of the combined battery and the flaw detector at around about 600 grams. We've got LEMO connectors, so you can connect any probe that you currently have. And we have USB-C ports in there as well, so you can connect other devices. The main thing about this is that we have a Wi-Fi generator here, which sends the signal of your probe to a tablet device. So this helps you to be very modular in the way you set up. You can put the hardware in your backpack or on your belt, and then you can have just holding the tablet with you on there as well. The battery solution is AA batteries we're using. That clips on there with a sleek bayonet connection. We've chosen AA batteries because it makes it flight safe, so you can take spare batteries with you on a plane. And also, inspections are carried out in the middle of nowhere, so if you need a spare battery, you can go to pretty much any store, and for €10 or $10, you've got a spare battery pack. You just fill it in. That gives you about 5 hours of battery life. If you need more, you could connect through this USB-C port a kind of off-the-shelf power bank, or even your mobile phone charger as well, which makes it very practical. You can use the battery solutions you already have to really help you out on there as well. So this wireless signal is sent to an iPad. It's the best tablet out there. There's a full range of different devices, which gives us the largest screen, the best quality resolution A-scan. If you are in a training school, you can use a big screen to promote. You can even use cast it up to a big television or projector, so then you can really show people what you're doing there as well. I personally like the iPad. It's a good balance between iPad mini. It's a good balance between screen size and weight. You've got 300 grams of weight from the iPad mini. And if you need extra storage space, you've got up to 1 terabyte storage space, which is kind of in line with the class leading phased array products. We have not compromised on specification, even though it's lightweight and small sized. We've got a 400 volt pulsar voltage in there. It's a true square wave. We can go up to 110 dB of gain. The signal to noise ratio we've got is excellent, so it allows us to use that full range. And the bandwidth, we can use from a 0.5 to 20 megahertz probe, which covers pretty much most of the applications. You can see here, here's an example of the excellent signal to noise. This is on a V2 block using a 70-degree probe. You can see even up to nearly 300 millimeters, you've got zero noise. This is because we've used the best-in-class low noise amplifiers. We've got the perfect square wave pulsar, so you can really get some excellent signals out of there, which helps you to resolve tips better, to inspect more difficult materials. We've benchmarked this against other systems, and it's class leading on the signal to noise. If we look at the hardware, what modes it can operate in, you can see it operates in pulse echo, both shear and longitudinal, so we have angle beam and straight beams. We can use dual pitch and catch, so we can have tandem probes or dual probes for corrosion mapping. And you can have through transmission as well for inspecting very